Okay, we're going to solve exercises of translational equilibrium. We need to understand that translational equilibrium only occurs when the forces in a system cancel each other. That means when there's a tie between two forces. Imagine two people pulling a rope, and if they have the same force on each side of the rope, then there's going to be a tie, and that thing is not going to move anywhere. So we call that kind of scenarios systems in equilibrium. Depending on where you have the equilibrium, if it's vertical or horizontal or both, we're going to have to do either a vertical analysis or a horizontal analysis. We never use diagonal forces into an analysis. So every time we find any kind of diagonal force, we're going to have to convert it into a vertical component, like this one, and a horizontal component, like this one. For vertical components, we're always going to use sine of the angle. And for horizontal components, we're always going to use cosine of the angle. With that in mind, let's try to solve a couple of exercises. So, exercise 1. For all of these exercises, we're going to have to find the magnitudes of the forces, okay? And they are all in equilibrium, and it's not mentioned that is vertical equilibrium or horizontal equilibrium, so we're going to assume that is in complete equilibrium. So, first thing we're always going to do is we're going to have to find the data. What is the data going to be in this case? Well, the data is going to be each one of the forces in each one of the 4 directions. Which force is going up? You might be thinking, no, there is no force going up. Actually, there is. This diagonal, as I explained before, can be transformed into a vertical force. It could go up or down depending on where the diagonal is headed to. In this case, the diagonal is headed up. So I know that the upward force in this exercise will be 82 sine of 30. Remember, we always use sine of the angle for basically finding the vertical forces. So, do we have a force going into the right direction? Yes, the same diagonal, only that in this case, to convert it from a diagonal force into a horizontal force, we're going to have to use cosine. We're going to use cosine every time we want to convert a diagonal force into a horizontal force. So it's 82 cosine of 30 degrees. That will be the force going to the right. Do we have a downward force? Yes, that is force B, which we don't know anything about it. And do we have a left-sided force? Yes, it's force A. With this data, we can solve now the exercise. How are we going to find those missing forces? Well, we're going to use a combination of vertical analysis and horizontal analysis. So we're going to begin with vertical analysis. Vertical analysis. So for exercise 1, we know that the downward force has to be equal to the upward force because there's a tie, because we know there is already equilibrium. I know already that there's a tie in all of the forces. They all cancel each other. So I know that downward force has to be equal to upward force. And for a horizontal analysis, we're going to say that the force going to the left side is going to be equal to the right-sided force. Now, which forces are those? Well, we're going to substitute with the data that we have in here. I know the downward force is B, and I know the upward force is 82 sine of 30. I know the left-sided force is A, and I know that the right-sided force is 82 cosine of 30. With that in mind, all I need to do is put those things in the calculator, and that's going to give me the answer. So force B is going to be 41 newtons. And force A is going to be 71.0141 newtons. Those two will be the forces that we were looking for. And with that, we solved the exercise. We found already the magnitudes of each force. That's all we have to do. Let's solve exercise number 2. Yes? In this case, the forces are in kind of like different positions. So let's do the usual thing. We're going to find the data first. Okay? What is the data for this exercise? Well, the data for this exercise is that the upward force is F2. The right-sided force is F1 cosine of 70. The downward force is F1 sine of 70. And the left-sided force is 50 newtons. With that in mind, we can solve the exercise. Actually, we could solve this one in here, okay? We could make a vertical analysis here, and a horizontal analysis in here. The vertical analysis tells me that the forces that are vertical are going to cancel each other. That means there's a tie. That means upward force has to be equal to downward force because there's a tie. There's equilibrium. I know that the upward force is F2, and I know the downward force is F1 sine of 70. Now, if you notice, this equation has two variables. That means I cannot solve this. It's impossible to solve. So let's try to focus on the horizontal analysis then. Maybe we can find something there. Horizontal analysis, I know that the horizontal force have to be equal in order to cancel each other. The right-sided force is F1 cosine of 70. And the left-sided force is 50. In this case, there's only one variable, so I can easily find this. All I need to do is pass the cosine to divide. So let's try to do that. F1 will be equal to 50 divided by cosine of 70. And if we put that in the calculator, well, we're going to get that the answer is 146.1902 newtons for F1. Now that I know F1, I can substitute it in the vertical analysis, and that's going to make things easier to solve. So all I need to do is copy F2, and I substitute. Instead of F1, I'm going to put the data that I already found for F1. I still copy the sine of 70, and then I put that in the calculator. If I put 136.1902 sine of 70, that's going to give me an answer of 137.3739 newtons. And with that, I have already found both of the forces' magnitudes. Okay? Both of the forces, I already know them by using a combination of vertical and horizontal analysis. This one was a little bit different than the previous one, so each exercise is going to have its unique way of solving, but it's always going to involve a vertical and a horizontal analysis. Now let's do this exercise. Okay, this exercise, data would be upward force. Do you notice that there are two forces that are going up? T1 is going up, and T2 is also going up. So I have two forces that are working together in this case. So I know that the first vertical force will be T1 sine of 35. The second upward force will be T2 sine of 40. Then the force that is going to the right is T2 cosine of 40. The one that is going downwards is 120 newtons. And the one that is left-sided is T1 cosine of 35. Remember, we use cosine for horizontal forces and we use sine for vertical forces. With that data in mind, all we need to do next is the vertical analysis and then the horizontal analysis. So let's see, vertical analysis. Vertical analysis. Okay, I know that the forces going up have to be equal to the sum of the forces going down. Yes, sum of the forces going up equals sum of the forces going down. Because there are two upward forces, I am going to add them because they're working together. So T1 sine of 35 plus T2 sine of 40. They're both working together. It's going to be equal to 120 newtons. Yes. Now that does not give too much space for a horizontal analysis, so we're going to move, but the data for horizontal will be T2 cosine 40 and T1 cosine 35. So we're going to try to do that. Okay? We're going to use T1 cosine 35 and T2 cosine of 40. So horizontal analysis. I know that the forces that are left-sided have to match the forces that are right-sided. That way there's going to be a tie, they're going to cancel each other, and there's not going to be any force affecting any object. So left-sided force was T1 cosine of 35. And that has to be equal to T2 cosine of 40. Now, do you notice that I have two variables in here, which makes this impossible to solve? And I also have two variables in here, which is also impossible to solve. So, okay, we're screwed. What do we do in this case? Well, we can pass this cosine of 35 to divide. It's not going to give us, like, a final answer, but we might find something that we can use to substitute T1 on the other side. So, let's try to do that, okay? T2 cosine of 40 divided by cosine of 35. If I put that division in my calculator, the T2 is going to remain. Wait a second, make a mistake. T1 equals. The T2 is going to stay there, but if I divide cosine of 40 with cosine of 35, it's going to give me the answer of 0.9352. T sub 2. I haven't found T1, but at least I have something that I can substitute it with. I'm going to substitute it in here. Once I do that, it's only going to leave me one variable on the other equation. So that's going to allow me to solve at least the vertical analysis. And then we're going to go back to the horizontal. We cannot do anything else in here, so we're just going to leave it there. And we're going to substitute in here. Instead of T1, I'm going to put what I just found. So I'm going to put 0.9352 T sub 2 sine of 35 degrees plus T sub 2 sine of 40 degrees equals 120. Now, if you notice, I have two variables, yes, but it's the same variable. So they are like terms. If they are like terms, that means I can add those things. I can simplify like terms. 0.9352 sine 35 plus sine of 40. I just need to put that in the calculator, and I'm going to get an answer that's going to simplify the exercise for me. So if I add those things, I will get 1.1792. And I copy the variable t sub 2. Yes, that will be equal to 120. This kind of like solves everything. I just pass this to divide, and I will have found already t sub 2. T sub 2 will be equal to 120 divided by 1.1792. If I divide that, I will get that t sub 2 equals 101.7639 newtons. So I already found t sub 2. I'm going to use this and substitute it in order to find completely t sub 1. So I go back to the horizontal analysis, and t sub 1 is going to be 0.9352. And instead of t sub 2, I'm going to put 101.7639. If I substitute that in the calculator, it's going to give me 95.1696 newtons. And with that, I have already found the force T sub 1 and the force T sub 2, which is the purpose of this exercise, to make sure we find all the missing forces, magnitudes. So yes, for the final exercise, we might have kind of like the same scenario, but the variables are in different positions. So this might give us a different process to follow. Always find the data, always use vertical and horizontal analysis, and then things are going to be popping up one by one. So data, which are the upward forces. Well, a sine of 60 is one of the upward forces, which is this one, yeah, a sine of 60. The other upward force is 85 sine of 30. Those are the two forces that are traveling, or, well, basically pushing or pulling up. The right-sided force is a cosine of 60. The downward force is B. And the left-sided force is 85 cosine of 30. Remember that we use cosine for horizontal forces, and we use sine for finding vertical forces. With that data, we can now do a vertical analysis and a horizontal analysis. Vertical analysis will tell me in this case that downward forces have to be equal to upward forces, because they have to be the same in order to cancel each other. So the downward force will be, in this case, B equals, the upward force will be, okay, a sum of a sine of 60 plus 85 sine of 30. Now, if you notice, I have two variables in here, A and B. That means that equation is impossible to solve. Okay? So let's try to do a horizontal analysis. Maybe we can find something there. Yes? If we focus on the right-sided and the left-sided forces, which are 8 cosine 60 and 85 cosine 30, we might find something. So, horizontal analysis. Will be that right-sided force have to be equal to left-sided force. The right-sided force is a cosine of 60. If you check the data, you're going to see that's the one. And the left-sided force is 85 cosine of 30. If you pay attention in here, you're going to see that there's only one variable. So this is possible to solve. I just have to divide this and I will find the answer. So I'm going to do that. A equals 85 cosine of 30 divided by cosine of 60. If I put that in a calculator, the answer should give me 147.2243 newtons. And I already found A force. So this thing that I just found, I can substitute it on the other equation. That way, I'm going to get rid of one of the variables. It's going to allow me to solve that equation too. So B equals, instead of A, I'm going to put what I just found, this thing, which is 147.2243 sine of 60 plus 85 sine of 30. If I add those things, I'm going to get the answer in my calculator. If I round, I need to round, obviously. I'm going to get 170.0000 newtons. Okay, that's if I decide to round the answers. So with that process, I have already found both of the forces that were missing on the diagram that we have in here. So that's how we work with translational equilibrium diagrams. In this case, this forces diagrams can be solved with a vertical and a horizontal analysis.